And we're back, and it's COMP397 at Winter 2016 semester, and it's week 9, part 2 of our broadcast. We just finished off doing island, ocean, and cloud. Let's do more clouds than one cloud. So you might be tempted to do something like this, right? So if I go to my play scene, here's my play scene, you might be tempted to do one of these. So cloud, I don't know, 1, right? Just saying. Right? If you want to do one of these, cloud 2, cloud 3, right? Well, this is really poor coding, right? And I could do cloud, add a bunch of clouds to the scene. I can do 1, and then 2, and 3, right? So I got 3 clouds. You might be tempted to do one of these things, but that's, I'll be honest with you, that's really kind of poor form, right? If you want to do one of these, right? So 1, 2, oops. 3. Look at all the extra code that I got in here. I want to show you this so that way you get it. Or maybe probably have a couple of these with that. And same thing goes here with the clouds. So a bunch of updates, right? I'm just saying, right? You might be tempted to do one of these, right? Cloud 1, cloud 2, cloud 3. And this is what you're going to get. If I save everything, so let's say unsuccessful save, whatever, I go back to here, and then I refresh my scene. And I go back to here, and I got 3 clouds, right? This is okay. This is what I want. I want 3 clouds to come onto the scene, right? But the code is really ugly. And you know what? I'm really duplicating what I'm doing over and over again. I mean, it does what I want to do, and it kind of looks neat, right? But it's not how I want to code it. Let's do a little bit of optimization. I haven't asked for optimization yet, but let's do it now, a little bit. So how do I make 3 clouds come into play, right? Well, what I want to do instead of 3 clouds is do a cloud array, right? So how do I do that? I'm going to do a private underscore clouds, right? And my cloud is going to be of type objects dot cloud, but it's going to be array. That's how you do it. An objects dot cloud array, right? That's how you specify it. So one more than 1 cloud. Okay, I don't need any of this. What I want to do is when I instantiate my clouds in my scene, every time I do that, every time my scene starts, get rid of some of this stuff, right? What I want to do is I want to instantiate my clouds by using a for loop, right? So I want to do something like this. I want to instantiate my clouds, and they're going to be added to the scene right away, right? So add clouds to the scene is what it's going to say. So I'm going to do this. I'm going to say for, again, number, var number. Gotta be careful what I use. I can't use just a number. Count, cloud count. Let's say count. We'll say count, right? Count is a number that starts off at 0, where count is less than. I don't have this yet. Cloud count. Put a cloud count in there. Whatever my cloud count is going to be, I want to do something like count plus plus, right? So that's my typical for loop. I don't have a cloud count. Let's make a cloud count up here. So I'll make it a private cloud count. Cloud counts. And I'm going to make it a number. And inside my constructor for this is where my initialization happens. I want to say this dot underscore cloud count is equal to 3. So 3 clouds. And in here, I'm going to say this dot underscore cloud count. Why am I doing it like this and just instead of hard coding it? Because I'd rather do it like this. Even this is bad. What I probably want to do eventually is in my config.ts, have the number of clouds here that I could change to test with. 1, 2, 3. Like for example, if I want to make this a multi-level game, I could start off with my cloud count being 1 for level 1 and cloud count being 2 for level 2 and so on. And so I can generate as many clouds as I need, right? All right, so let's go back to my scene. I'm not dealing with more objects. I'm just in my scene now, so I'm going to go to my play again. So here's my cloud count. I want to instantiate my object, and I'm going to instantiate my cloud array here in my constructor, right? This is the right place to do it. Or if it's not in my constructor, the other place to do it is in my start method, right? Either one is okay. Let's do it where I like to do it. I want to touch my constructor typically, right? I want to do it in my start method. So in here, I want to do that this dot cloud count. So this is my initialization. And if I have enough to initialize, it tempts me to put together an initialize method, right? And I might have that later on in my game. All right, but here's the other thing I want to do. I want to say this dot underscore clouds, right, is equal to a new array, right, of type objects.cloud. That's the syntax. So this is, I'm instantiating my cloud array. I'm not using it's empty right now. Instantiate cloud array, right? Here for cloud count, right? This is set the cloud count. Set cloud count. So whatever my clouds are going to be, right? I haven't added my clouds to the scene yet. I'm just instantiating my array here in my initialization step. Okay? I got my ocean on my island. Now here's where I want my clouds to be. I got to put them in the right step because my ocean, my island, then my clouds come into play, right? So I'm going to say something like this. This dot underscore clouds, clouds number, whatever the number of the cloud is, or sorry, count, whatever my cloud count is, 0, 1, 2, whatever. And you know what? Maybe the name count is wrong. Maybe I want to use cloud, which is kind of like for every cloud in clouds, you know, kind of thing, right? Sorry, I'm just kind of renaming it here by hand, right? So cloud lowercase c doesn't exist here in this context. It's just because remember, I'm not instantiating a cloud here. I'm instantiating a cloud array. So that's okay to use cloud. It's not going to clash. So this dot underscore clouds cloud, the cloud in the clouds array, right, is equal to a new objects dot cloud. That's what it is. See? So I'm taking a new object. This is class composition. All right, going back to composition. This is another way we do it. We do things in classical inheritance, right? We compose a class that has an object, and now I'm going to make a number of, I'm going to use a number of the same object to put it into an array of those objects, right? Now, before I do that, I'm also going to do something like this. I'm going to say this dot underscore clouds cloud is what I'm going to add into the scene, right? So I'm going to say this dot add child clouds cloud. That's what I'm going to do. So I'm going to add this cloud to the scene is what this is saying. Make sense? It's a little bit of weird syntax, but I mean, it's understandable if you see what I'm doing. So again, I'm making a for loop. Here's my for loop. And I'm counting from 0 to the number of clouds, so three clouds. Then I'm saying the first cloud, the 0th cloud, instantiate a new cloud object and put this inside my cloud array. Now, the other way I could have done it, instead of running it like this, is I could use the clouds.push. I could push an object onto the array as well. Okay, so there's two different ways of doing it. Remember, in JavaScript, arrays are arrays, but they're also lists, right? So I can play with JavaScript as lists or arrays. And I could have used a for in, right, as well. Let's use a for in down here. So here's a different kind of thing. So what I want to do is I want to say something like this now. I want to do another, inside my update, I want to do this. For var cloud, right, in, that's a new structure. In clouds, this dot underscore clouds, right, for every cloud in the clouds, right, I want to do this dot underscore clouds, cloud, right, dot update. That's a for in loop, right? Very popular loop for array type structures, right? This number here goes from 0. It counts how many clouds it is. Clouds, to the number of clouds there are. Does that make sense? No? I could change this to a regular for loop if you want. Which one? Update with brackets. That's a method. Oh, sorry, let's try this out. So this dot, you're saying this dot, or just cloud dot update. But the problem is, when I do this, see what happens? The reason why is this happening? Because in my var, it can work. But if in my var, I should define this as an objects cloud, right? And then it should work. But notice that when it gives me this problem, it says cloud, the left-hand side of a for n statement cannot use a type annotation. It has to be either a number, it has to be a number. So if I could do for each, if I want to chalk, this is one way of doing it. For each is I can go for each. And if I click for each, this is what my for each looks like. Array, whatever my array is, and here's the element. That's what you're talking about, right? So my for each structure is like this. The array, which is this dot underscore clouds, right? And the element is going to be what it is. The element is going to be the cloud element, right? And then I could do something like cloud dot update, right? That will make sense. That's what you're talking about. That's different than the for n. For n, for each, two different things. The for in is like a for loop, but it does, instead of me knowing how many clouds there are, like less than cloud count, I don't have to do that. I can say for every cloud in clouds. That's all it does, counts it for you, right? This way, the for each loop says, I don't know how many clouds I have, but for each of the clouds, update them. This is cleaner for our method, right? Okay, do you understand this methodology? Now, when I save it, just to see what it looks like in real JavaScript, right? If I go to real JavaScript and see what it looks like on the clouds, it says this function. Remember, because I use fat arrow functions in TypeScript. TypeScript, my cloud looks like this, right? Fat arrow represents it just takes the place of a function, right? Okay, but this is, for me, it's a lot cleaner. It makes more sense that the fat arrow function, or a so-called lambda function, right, also looks nice like this. All right, let's check this out. Let's see if this works with what we're doing, right? So I'm going to just go back to my scene here and refresh. And if everything goes well, if I click start, then I have the same idea, 3 clouds, right? But in this case, it's not hard coding it anymore. I don't have to say cloud 1, cloud 2, cloud 3. I'm not using silly methods. This is the proper way of doing it. Okay, and it's looking nice. Looks nice too, and it's actually more performant than the other way. Okay. So I've got my clouds array. Everything works nice. I need a player, and this is where we get a little bit fancy. Okay, so let's go back. I need a new object, right? We took a bit of a cloud break for a second, and I don't want to do that again, so we don't have time, right? I want to go to player.ts. That's the new object I want. My player.ts. I could call it plain, right? Plain instead of player. I'm calling it player because I want to be able to easily see my play scene and see what my player is. Even though it's a plain, tomorrow it could be something else. So that's why I'm making it generic. And so I could make a plain class, but it's not really a plain class. It's a player class. It's just a plain object that I'm using. That's why it makes more sense. Okay, I'm going to write this class from scratch because it doesn't resemble either of my object classes. My game object class doesn't make any sense for this one, right? It's a bitmap, but I don't have any scrolling. I don't have a lot of the stuff I have, so it really doesn't match my game object, right? So let's try this out. So I'm going to say module objects, and I'll say export class player. And my player, of course, is going to extend the bitmap class now. Extends greatjs.bitmap. And you're going to see why I'm departing from that whole thing. It's going to be some duplication, but it's not as much. Constructor. And in my constructor, I've got to call my superclass, which is going to be the name of my bitmap, which is going to be, I'm going to use this assets.getResult. And inside there, I'm going to pass in the plane. That's going to be my player, right? So my player is instantiated this way. And this is my player class. Here's my player class. And in my superclass, I'm declaring my player as right here. I need a couple of things to my player class. I do need to make my reg x and my reg x and reg y values in the middle of my player, not the top left corner. So it's going to be, that's where it's going to that's why I'm saying it's departing from the other class a lot. And if it's a lot enough, then I don't have to use the game object superclass for this one. I could, but that means that I have to really go back to my game object superclass and rework it so that it's a little bit closer to a generic, more of a generic class than it is right now. All right. So I know to have a width. So I'm going to say private underscore width. I need to know have this a width, which is a number, and I know I need a height. So I'm going to have to generate a height and width calculations. Eventually, it's a number as well. So I need those two things for my player, right? And inside my constructor for my player, what I want to do is say this dot reg x, right, is equal to this dot get bounds dot width times 0.5, which means I'm going to look at the middle of the width of my object, depending on how big it is, and I'm picking right that middle object for the middle of my registration point. And I'm going to do the same thing for my x value. This dot reg y, right, is equal to this dot get bounds dot height times 0.5. So half the height basically is what this is. Make sense? Well, that's kind of weird. Half height, and I made height and width, so I might as well do width and height here first and put width and height instead of get bounds dot width, get bounds dot height. So let's do that first. So I'll say this dot underscore height or width. I'll say width first is equal to this dot get bounds dot width. Sorry, and this dot underscore height is equal to this dot get bounds dot get bounds dot height. And then I can replace this width by this width. That's what I really want to say. And this height by this height. So that way it's a little cleaner again. So I do one calculation, then I base it on the other one. Okay, so this is the first thing I need to do. All right. I never need to reset my player. I'm never going to reset my player. But I need to know my left boundary and my right boundary, right? And I already have these things here, but I'm going to put them in as different things. So private, you see some of the similarities. So I'll say left bounds is a number, and private right bounds, that's another number. So what's my left bounds and right bounds for my player? Now notice I told you before, if I do a lot of this, this calls me to use some kind of initializer class or initializer method that I might want to go to later on, just from a form perspective. Well, I want to calculate the bounds. So I want to say this dot underscore left bounds. What is that? It means that it's 0, right? Plus, this is the problem with this with the thing, half the width of my character. That's where it's going to start because of my player. Let me show you my player again. If I go to my plane, here's my plane, and if I take my plane now and I go back to this thing here and put them in, right, here's my plane. Just my demonstration perspective. My plane now, the registration mark is not like my island and not like my ocean and not like my cloud. The registration mark of my island is the top left corner, right? That's the pivot point, if you will, my focal point. Well, my player, not so, it's in the middle. So wherever I put my player, it's going to be, if I put at the middle, it's going to be like this. So I got to take this plus half the width. So that's the left bounds. All right. So the left bounds then, right, is equal to 0 plus half the width. So I'm going to say this dot underscore width times 0.5. Right, half the width of my thing. That's the left bounds. So what's going to happen is I'm going to say if I go there, that's going to, let's say my plane is 65 pixels wide. By the way, I know it's 65 pixels wide. Well, that's because I've done this game over and over again. So it's 65 pixels wide. It means I'm going to take half the width, so 32 pixels approximately, right? And then what, or 32? Yeah, 32 and a half. And what I'm going to do is I'm going to take that 32 and a half pixels, and that's the point, it's the center point of where it's going to start on the left bounds. Because I'm going to check my left bounds to see if it doesn't go, my plane should never be able to leave my left bound on my screen, yeah. Sorry? Times by 0.5. Half the height. Yeah, half the width. Sorry, half the width. Yeah. 0.5 is half, right? I don't want to do, here's what I don't want to do in when we make games. I told you guys this before. I'll say it again. We make games on this platform or any other platform. I want to avoid division at all costs. The division, unfortunately, every frame is a heavier mathematical calculation, believe it or not, than multiplication. Multiplication is easier on the computer from a performance perspective than division. Still, people used to say, "Oh, it's not true." It's true, right? Let's go right bounds. Right bounds is equal to this. So again, now this is where it's a little bit funny. Right bounds is the right part of my screen, right, which is my config.screen.width, right, minus half the height of my object. This, or half the width, I mean, this dot width, this dot, no, we'll trigger, this dot underscore width times 0.5. And I got to make sure that this is in the correct order of operations. So I like to put this in brackets just to make sure that this is, I get a number, right? Half the width time minus the screen width. So screen width, so 640 pixels, and then minus the width of half the width of my object. So I never can go outside that range. I want to establish this now because when I do a boundary check, right, then I want to put my guy back to the left bound. I never want to go out of left bound and right bounds for my character, right? Because otherwise it'll be half out of the screen. Never want to do that. Okay. Okay, enough. Let's say I think I've got enough of this. What I want to do now is every update is my update function, and we'll make this public, of course. Public updates, and then this returns void. In my public function, my public here are public methods. I want to look at my mouse X and mouse Y, and wherever my mouse X, mouse Y is, for now, I don't care about my mouse, my Y component. I always want it to be at the bottom of the screen. I'm actually limiting my character, and this is me to make the game more challenging. What I'm doing is I'm not allowing the character to move with my mouse everywhere. I don't want that. And I don't want you to do that either. I want you to limit him to one part of the screen. If you're doing a side scroller, it's going to be somewhere over here or somewhere over here. I don't want you, or maybe limit him, so maybe you only make it this much. I only want to limit him so he moves, he's just here all the time. So he can only do left and right movements. Because if I let him do this, it's too easy, right? So all he's going to do is stay in the middle, like right here. And by the way, the value that for the Y value is 430. Again, I know this because I've tested it out a bunch of times. So here, inside the initializer, my constructor, I'm going to do something like this. This dot Y is equal to 430. That's never going to change. However, my X value is going to change. It's going to change every frame. This dot X is equal to this, so scene, or sorry, stage dot mouse X. You'll notice I went right to the stage object. The stage, not the scene object, the stage object, which is my canvas. I'm saying wherever the mouse is on the canvas, that's where my X value is going to be for my plane. So it's going to move along with my mouse. Now, if I want to make it a little bit, like, you know, so it's a laggy mouse, how do I make it a laggy mouse? So it's not exactly where my mouse is. What would I multiply by? 0.9, let's say. So it's going to be like 0.9 of my, eventually it'll get there. If it keeps on multiplying by 0.9, 0.9, 0.9, it'll follow up and get there eventually, right? Think about it, right? But if I make it exact, it means like whenever I move, so is this thing. It's going to move exact. Just see how funny it looks. Let's try this out. So first I'll do this, right? This dot X is equal to stage dot mouse X, okay? My plane is done. My plane is done, right? Let's add it into my scene. So index.html, I'm going to add it underneath my cloud here. Scripts, objects, player.js, and then script. Cool. And then I'm going to add it into my reference card and my core with my reference card. But I'm still got to do my boundaries, right? I haven't done my boundaries yet. Let's just add it in first. Reference path is equal to objects player.ts. Okay. My player is in. I did everything, and now I've transpiled. Here's what my player class looks like, and I need to add it to my scene now. Let's go back to my scene. So let's go back to my scene. So here's scenes, play, and I've got my ocean, my islands, my clouds, and my cloud count, and then I'm adding my player, private player, which is objects.player. By the way, I could have made a plain object and called my player my plain objects.plain. Right? I could have done that too, but I just wanted to do it this way this time around, just to make it different. Okay, where should my player go? Should it go before my ocean or after my clouds or somewhere else? Where should it go? Before my clouds and after my island, because it's going to be above my island, but underneath my clouds. All right, that makes sense. So this is a good place to put it. So I'm going to put it in here. I'm going to say added player to the scene. And I'll go this._player is equal to new objects.player. And I'll say this.addChild, this.addChild, this._player. Now I'm getting an error. What does it say here? It says player is not assignable to type player. What did I do? I don't know what I did there. Player, both more than one player. 5 players, right? Multiplayer. I could do that. But no, let's not do that right now. So player, 1 player. So we got that player. Let's test it, see if it works. Right. So if I test it out and refresh it, hopefully we'll have our player on the scene. And oh man, I forgot to do something. I forgot to do my updates. So I'm going to update my player before my clouds, just to be in the order that I'm putting it in. So this._player.updates. There we go. And did I transpile? 5243. Yes, I did. That's good. And now if I go here like this and refresh and go scene, then now if you notice, I move my player around and I've got my almost my game, right? So boom. I go here, I go here, I got my points I just got collided with, right? And that's cool. All right, so wherever my mouse moves, right, my player goes. And notice that now I'm here, but I don't want that to happen. I want to stop my player here, right? So this is where I have my bounds. So let's go back and change that in my player class. So I'm going to go back to my player. And in here, I want to check my bounds. And I want to check it every update. I'm going to say this. I'm going to say if this.x, right, my value of my x, is less than what? Come on, guys. This._left bounds, right? Then this.x is equal to this._left bounds. Right? Makes sense? So it's going to equal to that. So it can never go less than it. And at the same time, if this.y is greater, or x, sorry, is greater than this._right bounds, then this.x is equal to this._right bounds. And you know, since I'm doing it like this, guess what I need? A method. Because I don't want to clutter my updates. So I'm going to say something like this. So here's my private methods, just to be clear. And in here, I'm going to say private. I will say call it the _checkbounds, right, which returns void. And in here, I'm going to do all this. Right? So cut this out, put it in here. And in here, I'm going to call this ._checkbounds, which makes more sense to me because that's how it's a little bit cleaner for us to look at. Make sense? All right, so that's my checkbounds method. So now what I'm expecting is I can never push my mouse more left. I can't have half a plane on the screen ever. So that's going to make my game a little bit more challenging. Otherwise, I can kind of avoid the clouds by going outside the screen. right? Which is a cheat, right? That's a cheat, man. I don't want to be able to have my player cheat. Let's check this out and see if it works. So refresh. And did it do it? Oh, it didn't transpile yet. Hold on. Again, sometimes what I find with this thing is I have to actually physically transpile myself or rerun gulp when I have a running value. Right now, if I refresh and I go back to the scene, I can't go back. See how it hugs? See how it hugs over here? Even if I want to, I can't. Hug, hug. Right? It's right at the corner. So it stops my player from going outside of my scene. Right? That's what it does. Okay, cool. I've got most of my mechanic down, but I've just added my player. Let's add it to GitHub. So I'm going to say add all this stuff. I'll say added player object to play scene, and then push that up to GitHub. There we go. Now let's add in some collisions. Now remember how we can do collisions. Collisions are a big problem with game production, right? And one of the problems are in Unity, we would use a collider, right? We would declare like a collider that's square like this, like a, a box collide equivalent, right? But not so here in Create.js. First of all, there is no colliders at all. There are none. And the problem is if I use the box collider here, right? Notice how, I'm going to try and bring this in so you guys can see this. Is there a visual collision here? A visual collision. Are they? Do you see that they're colliding? No. But how about is there a collision if I did this? Yes. So this is incorrect, right? Because there's no visual collision, right? But there's a collision, right? So then it begs to kind of ask the question: if I was going to combine this, what I really want to do is, and this is what the truth is, when I'm colliding, and because it's a top-down game, right? My other option is to do this. If here's the height of this one, right? Height of this one, and here's the height of this one. If the distance between the centers of this one and the center of this one, right? If it's less than half the height, right, of my objects, then typically I'm good. I have a problem. What's my problem? What's the center of my island? How do I figure that out? My center of my island is half the height and half the width. But that means that I haven't calculated the center. Uh-oh. Game object, right? I have to calculate the center of my objects. And usually it's the registration mark. So for me, X and Y for my plane is my height, my middle. But for my other things, my height, my cloud especially, so I'm also going to do my cloud. I'm going to calculate the distance from the middle of my cloud out to my player object, right? So there's two things I can do here. I'm going to go back to my game object class, right? So here's my game object class. I'm just thinking it through with you, right? And I've got my width and my height, right? But I need to know the center, right? Center X and center Y. So center X and center Y, right? Center of my plane, center X and center Y of my object, right, is what I'm looking at. And all I care about really is half the height, which is really my center Y value, right? Because my Y value has to come down. So center X and center Y. Let's calculate them here in my super game object here, right? So that's my center X and center Y. I'm going to make a couple more protected values. So I'll say center X, right, which is a number, and protected center Y, which is also a number. And I can calculate center X and center Y by doing this. This dot underscore center X is actually equal to the width, this dot underscore width times 0.5, right? And this dot underscore center Y is equal to this dot underscore height times 0.5. Okay, make sense? So I've got these values. I've just updated my superclass. So I got to go from the center Y value, which is half the height. In your case, because you're doing a right to left game, you do half the width because it'd be coming at you this way. And in most cases, it would work. And the reason why is sometimes you have something goes like this, which is rare, right? But you're going to still calculate the distance. All right, cool. All right, so how do I do this? How do I calculate the distance? I've got my class. I've done this piece, right? But in my player, when I do collisions, right? When I check my collisions, I want to do a collision check here. Check collisions over here, right? That's what I'm going to do, right? It's almost like I need a collision manager, right? My collision manager is going to be a class, and all it's going to do is going to check collisions between one object and another. And my collision manager is also going to have a bit of a utility class that checks the distance. So I don't have a check distance here at all. Like I don't know the distance between 2 points in Create.js. I don't have that utility function, right? So I need another class, and it's got to come under, when I start doing collisions, this is a little bit of the work. I don't know if I'll finish everything today, guys. I'm sorry. It's going to take me time just to build this. But what I want to do is I want to go new folder. Try this out with me here. And under my folder structure, I want to put something called managers. Right? So this is a different thing. I've got objects and I've got managers. And one of the ones I want to put together is something called collision manager. So let's do that. So right click, new file, collision. Right? Here's my collision. So notice that my object, oh, I better put a collision. How about collision.ts, Tom? Right? Knowing that I'm going to make a collision manager, collision.ts, and I'm going to add it into my game scene. I don't want to forget, right, kind of thing. Let us do something, and what I want to do is I want to add it into my game right away. So I'm going to go into my index.html, and inside my index.html, I want to put my collision manager here underneath my objects. So it has to know about all my objects, which is the right place to put it. So here's my script, source is equal to scripts. And then instead of objects, it's going to be managers, and then collision. So there's my collision manager. So kind of a new idea that we're kind of putting in. I could do it within my play class, but it's really, I want to be able, maybe I have more than one play class. Maybe I have level 1, level 2, level 3. I don't want to have each one of them have a collision manager of their own. I want to use a global collision manager that I can instantiate as many times as I want. It's a little bit of a different concept here. Okay, managers collision. I also need to put this inside my reference card. So here's my reference card. Now it's going to be slightly different. Again, it's going to be before my scenes. And I'm going to do something like this. Reference path is equal to /managers and then collision. Yes. Okay, there's my collision class. It's in there. My collision class right now is empty, and I need to start coding. So it's going to be module instead of objects. It's going to be managers, right? And then export collision, capital C. Here's my collision manager, right? And my collision manager is going to have export class. How about class collision? That'd be nice, Tom. Class. Here's my collision class. It's going to have a constructor. This is not going to be a derived class. It's going to be my own class. I'm not going to derive it. I'm not going to extend anything else. This is going to be my own little class here. All right, so here's my collision manager class. Here's my collision manager class. I'm going to call it collision. All right, cool. Now, I could also call this collision manager, managers.collision manager, right? But managers collision makes sense. Collision managers. Okay? All right. Some people may want to do this, may want to put something like this because collision manager.collision. I might use collision as a method. I'm just trying to, again, I got to think this through when I put this thing together, right? So here's if I put collision manager.distance, right? How about just collision.distance? So that sounds better to me. Collision.distance, right? If my collision.distance is less than da-da, then, right? All right, so that's the first thing. Now let's create that distance class or the distance method. So I'm going to call this first method, it's a utility method that's going to be public, and we're going to call it distance. my distance calculator. It's going to return a number, right? The distance between one object and another. My distance is going to return. Here's my return now. So here's what I'm going to get. In my distance, I'm going to have two values: my beginning point, my start point, and my end point, right? So start point, right? And by the way, when I say point, that's a good thing that I need to use points. So create.js point class, and then my endpoint, which is endpoint, which is a create.js point class. So my beginning point and my end point. And notice that I'm going to return two values. Start point and end point is going to be something. So what's the formula, my distance formula from one point to the other? How do I do that? If you guys don't remember, it's the square root of x2 minus x1, squared plus plus y2 minus y1, y2 minus y1 squared. Right? That's the square root of. So how do I do that? How do I represent that in one line? Right? It's this: math dot square root, so the square root of, that's the first thing up, the first thing. And here's the first part. Math dot power, right? Math dot power of the first one, which is, and again, if you look at math dot power, right? Math dot pow, and it looks like there's two numbers, x to the y, right? So my y I know is to 2, right? But my x is what I have to calculate, and it's going to be the difference between start point, or sorry, x2, which is endpoint dot x minus start point dot x, right? So that's the first one. Plus math dot power, right, to the 2, right? It's going to be endpoint dot y minus start point dot y. And that's what it's going to return. It's kind of a big one, right? Now I'm using everything in one line. Could I have broken it up into different lines? Yes, I could have. Would I have needed more variables? Yes, I would have, right? So I'm just doing it in one line. Math.square root is on the outside, so I'm taking the square root of the differences between my x's and y's, and they're going to in there, so it's going to be like the formula is going to be that distance formula. For those of you who know what the distance formula is, I can always look it up. Distance between 2 points, right? And if I was to look at it, it's just like this, like it says. So distance formula. And does it give you the distance formula finally? Here it is. So it's c squared is equal to x2 minus x1 plus, right, y2 minus y1, and they're all squared. And then it's the square root of those two values, right? That's what it is, and that's how you figure it out. This is the formula right here. Distance is x2 minus x1 squared plus y2 minus y1 squared, and I'm doing that here. That's what the value is. Okay, so if that's true, I can find the distance now. If I call the distance formula, it's going to return when it's going to ask me for these 2 points, right? Point 1 and point 2, and I can put in the points that are in there for my distance formula. That's the first thing I got to do. Second thing, if I'm going to make a collider, right? And I'm going to take in a game object, right? My game object is what I'm going to compare with my player all the time. It could be a cloud, or it could be a island, right? So here's my collision. So collision.collider, let's say. I'll call it collider. I know it's got, please don't think of it as a Unity collider. It's not the same, right? So public collider, right? I'm going to do a collider check, and I'm going to say I'm going to take in the object, lowercase o, right? Object, and it's going to be of type. Here's something where it's going to, you're gonna hate me for this one. Objects dot game object, right? And I'm going to return if it does collide, it's going to do something. right? So I don't know what it's going to do. I could say check collision, like check, collision.check, right? That could also be something that I could do because it should roll collision.distance, collision.check, like instead of collider. So we can call this check. Right? And here's what I'm going to do. I'm going to say if my object, and again, this is something that I want to talk about a little bit here. Can I do a type check, right? In JavaScript? And the answer is yes. I can use something called the type of function, type of JavaScript. If I look at the type of JavaScript function, it's the same thing that exists here in this. And here's some examples of this. So type of 37 is number, right? Is equal to number. I can do that. Is exactly equal to number. I say if type of object is exactly equal to cloud, objects.cloud, right? Then cloud hit. If type of object is of this, then island hit, right? Depending on what I do, right? So that's the first thing I want to do. I can test which one it is based on the type. But what's the easiest way? That's another little check I got to do. The easiest way to do is to hold what type of object it is in my class. Let's go back and fix that. So back to this, and I have my island, and I have my different objects. Well, in my game object is going to have another property, protected, a property called, and now is it protected? No, it's got to be public. It's the only public property I'll have so far, which is name, which is a string. Right, so here's my private, and here's my public. Now I could make a getter for this one if I wanted to. I just don't have the time right now. The proper thing to do is to make a getter, right? So if that's true, then if I go back to my island, I'm only checking for my island in cloud. Inside here, I'm going to say something like this. Because it's my island, I'm going to say this dot name is equal to island, right? Island. And the same thing goes with my cloud, right? I can say something like this dot name is equal to cloud. Why? Because now I can check names. I don't care what object it is. It's either a cloud or an island, right? And when I do my collider, when I do my collision check, right, which is here, I can say, depending on what it is, if my object is a cloud, then I can do this. If my object is an island, then I can do this, right? I don't know what my object is yet, but it's a type game object, and they all have names, right? Okay, here's what I want to do. I want to check the distance, right? I want to check the distance. So I want to do something like this. If, first of all, before I do any other check, if my distance, right? So what am I going to check? It's the distance. This dot distance. If this dot distance of my start point, which is my start point is my my player, right? And my endpoint is going to be my other object, whatever the object is. So my player is going to be the start point. So start point would be my player. So player, my player dot x, my player dot y, but I could put it in brackets like this. So player dot x, comma, player dot y, right? That's my start point, right? Comma, and here's my end point. And as you notice, something's going on here. Player dot x, I can't find the player, right? I don't know what that is. There's no player, right? Because objects doesn't have anything. Objects.gameObject is the first one. Well, what I could do is, remember that my collision doesn't know, my collider doesn't know about my player, but I could give it the knowledge of my player. How could I do that? By passing it in. I don't know what my player is going to be, but I will know now, right? Because in my constructor, I'm going to ask for my player object, right? Player is of type objects.player. So I'm going to always have a reference to my player in my collision class. And then that means that my collision class is going to carry a private, here's my private instance variables, inside my class, I can say something like this: private underscore player, to keep it separate, is equal to, is of type objects.player, right? And then inside my constructor, I could say something like this. Oh wait, I could probably do it at one blow, but I'll leave it like this for now. This dot underscore player is equal to player. So I'm making a reference to my player class from here, and now I'm doing this dot underscore player x, and this dot underscore player y, right? And it says argument of type number is not assigned with member of point, right? So what does that beg me to do? I need to create a location object that's of type point for my player, and I want to pass my player's location into this object. And hold on a second, that means that I need to do the same thing for my my game object. So I have my points, because they're all points. This isn't a point. Or I can define a point, point 1, point 2. Maybe I'll do that. Makes it simple. So var point 1, I'll call it start point, just to make it easy. Start point is equal to is of type create.js.point. That's what I have to do first. And it's equal to, I'll do right in the thing, a new create.js.point class. Right? And the same thing goes with my endpoint. Little setup, but you'll see what I'm talking about. Create.js.point is equal to new create.js.point. And inside there, I could say something like start point x is equal to this dot underscore player dot x. I could do this, and then start point dot y is equal to this dot underscore player dot y, and then endpoint. I don't have to make a lot of changes. Dot x is equal to this dot underscore object, whatever the object is. Object, this, no, this object, just object. Object dot x, and then endpoints dot y is equal to object dot y. Okay, now I can do in here in my class, my distance, I can say between the player start point and then endpoint, like it's waiting for, right? So take my start point and endpoint. If this distance is less than half the width plus half the height of my player plus half the height of my whatever that is, whatever my option is, right? Half the height of my object, right? How do I figure that out, right? Well, I know my height, so if I say I know my player is this part, and I can do this. I can say, well, there's different. I'm trying to just calculate this a little bit. So half player height. So I can do something like this. I say var some setup. I'm doing this every frame, right? var player half player height, half height. So player half height. Player half height is a number, and I'm going to make it equal to this dot underscore player dot height. Do I have player height? I should be a value. This dot player height times thing. Why is not coming through? Player.ts. Player height, underscore, it's private. That's okay, because I can make it public. And I can rejig these things for a second. There's some things I have to think about, right? So, and now I'm going to rejig this. I'm just going to rename my symbol. Rename my symbol on my player, rename symbol to height. And rename my symbol to width, just so that way it's not impacting. So width and height, and take these values here and put them over here, and put in private instance variables. And this is public. Again, I should probably create a public instance variables. I should probably create a getter and setter. I just don't, I'm out of time, 6:20, right? All right, so half height. And what I want to do is go back to my collision here and go player height times 0.5. And oh, I'm going to have the same kind of problem, right? I have the height of my object, but unfortunately in my game object, here's my height and width are both protected values. So we're going to make these, we're going to unprotect them. We're going to make them public again over here. So we have access to them. Okay? Otherwise, we're going to have some problems. So, comma, and just reword these, rename. So we're always going to have access to those options, width and rename height. Otherwise, it's just going to be too complicated for us right now. And I really don't want to complicate it any more than it is. So I've complicated it just because I've made classes, and then you're going to, I don't want you guys to flip out even more. Okay, so good. So that's my player height, and then my other object height, var object half height, is a number that is equal to this dot object dot height times 0.5. Yep. So I calculated once. And so what I'm going to say is the difference in height now, I'm going to break it down so that the next line is so var, height difference is a number that's equal to player half height, right? Actually, it's not, it's total height. It's total, not the height difference. But I'll change that. Player half height plus the object half height. That's what it looks like. And then this is not the difference. It's object or minimum distance is what it is. Min distance, minimum distance. So the minimum distance is player half height plus object half height. And what I'm testing is if this distance, start point and end point, is less than the minimum distance, then what do I have? I have a collision. I don't know what collision I have yet, right? I have to detect it. I have to say, well, I have a collision, so let's just, for now, let's just test and say collision. So I'll see that my collider is working, right? Collision, yay, okay. And now that I've done that, I need to instantiate my collider in my play class. So here's my my new object. It's going to be a private collision class. So I'll say collision, right? Underscore collision. This is my play, which is of type managers dot collision, right? And I'm going to instantiate it here at the end after everything else, but before my add child. And I'm not going to add it to the stage. This is an object that I'm going to be using to check stuff. So I'm going to say stage.addChild. I'm not going to do that. I'm going to say added collision manager to the scene. And the way I'm going to do that is I'm going to do this. I'm going to say this dot underscore collision is equal to a new object, sorry, managers dot collision. And notice that it needs the player object, which is this dot underscore player that I'm going to pass into it. Right? So I pass a reference to my player from this class, from my scene class, into the collision class, right? And now I can check to see if my player collides with any other object. All right, let's check this out before we go, because if once we have a collision, we can do sounds, we can do score, we can do everything. Yeah. We will do the check. We will do the check in our update, right? So I'm going to do in my update at the bottom. I'm going to do this dot underscore collision dot check. Now, if you notice, collision dot check, it says supplied parameters need an object, game object, and I want to check it with both my plane, my island. So I'm going to do my, I'm going to pass in my island. And I also want to pass in my clouds, but guess where I'm going to do that? Here in my for loop. So this dot underscore collision dot check with this dot, or with the cloud, whatever the cloud is. That's a cloud object that I'm passing in. So I'm checking the collision with my cloud. I'm checking the collision with my island. And depending on what I get, I should get a collision. Make sense? That's how you do the collision checking. And it's by distance, between the distance between the middle of one object and the middle of the other object. Half the height of each object. Whew. Just saying, right? Let's see if we get this. Now, is this accurate? And I'm telling you right now, it's not accurate. Here's why it's not accurate. I made a mistake. I can tell you right now. When I decided my endpoint, which is my object X and my object Y, my object X is the top left corner of the object, and so is my object Y, right? Can't be that. It's got to be my X plus half the width and my Y plus half the height. And I already have that, center X and center Y, right? So that's what this has got to be, not X and Y. It's got to be dot center, center X and center Y. I don't have center X and center Y as part of my my object, right? Did I add them in, or is it just in my island? Game object. Oh, I have to make them public. Once we start making more public items, then I start worrying, right? That just means, sorry guys, I know I'm running over. I'll put the complete solution online for you later. So I'm gonna rename this symbol. Sorry, Peshmek. Shemek.
You still have 3 minutes.
I'm working. Okay, there it is. So center X and center Y are now public. That's what I want. I don't care about my height and width, because that's my height and width is one thing. I need my height and width, but I don't need my X and Y coordinates in the top left corner. I need my center X and center Y. That's what I need. All right, so that's kind of a difference. It's kind of a change. So in my collision, my endpoint can't be object.center X and object.center Y, because that makes more sense, right? Otherwise, we'll have a weird collision. Okay, cool. Center Y. Again, there's different ways of coding this, guys. I don't want you to think this is the only way, but this is the way I found that's tried and true, right? So let's go back to this, refresh, and see what I've got. So here's my game, right? I'm playing now. I cover over here. I should see a collision, right? Let's see if I should see any collisions, right? Because maybe I don't see any, right? So here's my console, and you know what I should be seeing here is collisions, right? So there should be a collision here, a collision, something, right? And I'm not seeing any collisions here whatsoever. What? This is part of the challenge I'm going to have, right? Because I have my plane mapped, and this is where I have to start doing troubleshooting, and we've run out of time, right? But what I will do is I will put a completed solution up online. Usually I do this in, like I said, 2 days. It takes me 2 days to write this thing, because, or 6 hours, because I'm talking as I'm writing and I'm not thinking properly, right? So here's the challenge. What's my distance, and how is my distance greater than my minimum distance? I've got to check this out. So what I want to probably do is do a couple of checks. Console.log. Actually, I do it here. And bear with me, Shemek, one more second. Console.log. I'll do this. I'll just copy this thing here, this distance, start point, end point. So what's my distance between my start point and my end point, right? Because I'm checking a bunch of times. I'm doing this public check function over and over again. So here's one. And if this is my distance, right, before I go to my distance check, what does that mean? So let's go into my file, refresh, and then start. And then now I see my distance, right, 665. I'm getting some massive values, right? But look, as I move to the left, my value is lessened. And as I move to the right, my value is, you know, is kind of different all the time, right? So depending on where I'm moving, it's almost like I get the value, right, of I'm here, I'm at 700 or 640, right? But this value should be changing. 700 is a pretty goddamn big value, right? So that's the first thing. Where am I getting that value from? It's a kind of a fixed value that I'm getting all the time. My distance formula is broken. Distance formula broken, doesn't matter what I do. I'm never gonna get a collision check, right? If it wasn't, then this wouldn't be this value. It should be actually changing more often, a lot more often than this, right? So that means my object that I'm getting in there, my object.game object that I'm getting, isn't good enough. It's just giving me the same value all over and over again. So how is that possible? How is that my thing happening, right? So I got to start showing these values. So things like show my start point, show my end point. Yeah. Sorry, say that again. No, that's not it. I said, I like your idea, it's not. Console.log start point. If I do start point, here's my start point, that's my player, right? And let's get rid of this one, and then I'll go. I swear. Here's my start point. And then if I go here and I refresh and I start, then this is my start point. Look, my start point's always the same, 320, 328 by 430. What's happening? It's not updating my player position. My player position in my scene, it's not being propagated to my collision, my collider. It's got to be updated every frame. I've got to get a reference to my player object every frame, and I'm not getting it, and that's my issue. So I got to figure out, how do I get a reference to my collider, to my collision object, every frame? How do I pass that in every single time? So there's two things. I can pass in two values, my player and my other object every single frame, instead of doing it in inside my constructor, right? So instead of taking one value, I take two values, right? That's my issue, and that's why I can't get collisions, but that's an easy one to fix. Okay, guys, thank you so much. I will put the completed solution with scoring and everything up online, probably later on tonight. Okay, so you guys have a pattern for you guys to finish your project with. Okay, my bad. I was sick last week. Otherwise, we would have been done this today. We were just been doing scoring. Okay, and sounds. Guys, thank you so much, and see you not next week, because next week's a break on Friday, but the week after in April.